All right, problems 7 through 12. Find the exact value of the logarithm without using a calculator. Number 7 says log base 1/2 of 8. So the first thing we want to do here is we're trying to figure out its value. We're going to turn it into an equation, and now we're going to change its form to exponential form. We know the base is going to be 1/2. We're going to raise it to the power of x, and it should equal 8. So we've got 1/2 raised to the power of x equals 8. Now we want to rewrite each so that they have common bases. So we have 1 over 2, which is really the same thing as 2 to the negative first power. And we'll still raise that to the power of x on the outside. And then 8 is really the same thing as just 2 to the third power. As we look to simplify the left side, we know that when you raise a power to a power, you're going to multiply those together. So we should have 2 to the power of negative x is equal to 2 to the power of 3. And in order for these two sides of the equations to be equal to each other, we have to have the same exponent here. So we'll just create a new equation using those exponents. The opposite of x equals 3, therefore x would have to equal negative 3. And that would be our answer. You can always go back and double check with the calculator after you're done. Number 8, same kind of things going on here. We've got log base 3 of the square root of 27. We'll create an equation, and now we'll rewrite it into its exponential form. So this is going to tell us 3 to the power of x is equal to the square root of 27. And now we're just going to look to take this and simplify it down so they have the same base. So the square root of 27 is like saying the square root of 3 to the third. And then we can take that and rewrite that. We know that's the same thing as saying 3 to the third raised to the power of 1/2. In which case here we can rewrite that as 3 to the 3/2 power should equal 3 to the power of x. And that means that x would have to be equal to 3/2 in order for this to be a true statement. So x equals 3 over 2. Number 9, same things going on here. Log base 5 of 1/125th equals, I'm going to go ahead and just call it x. So we're going to say here our base is 5 raised to the power of x should equal 1/125th. Now I know that 125 is the same thing as 5 to the third, so this is like 1 over 5 to the third, and then if we want to move it to the numerator, we're going to end up with 5 to the negative third power is equal to 5 to the power of x. Therefore, x is going to have to equal negative 3. All right, looking at 10. 10 says log base 0.01 or 1/100th of 0.001, which is 1/1000th. Okay, so we're going to do the same kind of thing here. Let's just set this one equal to x. We'll go around the world or use the giant spiral. And we have 0.1 as our base raised to the power of x is equal to 0.001. So as much fun as it is to work with decimals, I prefer fractions. So I'm going to rewrite these right now as 1/10 being, oh, I'm sorry, I wrote that wrong, didn't I? That should be 1/100th. So 0.01. So when I rewrite that though, that's just going to change that fraction to 1 over 100 to the power of x. And then I said this one was 1/1000th, so I have 1 over 1,000. And now we need to try to rewrite these with the same base. So 1/100th is like 1 over 10 squared, which we could rewrite as 10 to the negative second power raised to the power of x. On the right side, 1 over 1,000, the same thing as 1 over 10 to the third, which then if we moved it to the numerator, we'd end up with 10 to the negative third. So our equation that we're looking at right now is 10 to the power of negative 2x is equal to 10 to the negative third, in which case we'll just pull the exponents and set up a new equation, and we'll get that x is equal to 3/2 or 1.5, and that would be our answer. All right, two more. Number 11 says log base 6 of the cube root of 6. So nothing changes here. Hopefully we're getting faster at that. We've got 6 to the power of x is going to equal the cube root of 6. Now we know that the cube root of 6 is the same thing as 6 to the 1/3 power. So we'll go ahead there and rewrite that as 6 to the 1/3 power. And that is equal to 6 to the power of x. And since we're trying to make this equal, we know that this exponent is going to have to end up being 1/3 for it to be true. So we'll take this here and we'll write out that x should equal 1/3. All right, last one here. With this one, number 12, it says log of 1/10. Okay, so we'll set that equal to x, but remember here, there's no base written there, so that means the same thing as log base 10 of 1/10 equals x. So if you need to rewrite it, that's totally fine to do. We'll do 10 to the power of x is equal to 1/10. And then we know if we wanted to rewrite this here, this would be the same thing as saying 10 to the power of x is equal to 10 to the negative first power, in which case x should end up equaling -1. All right, that's problems 7, 8, 9, 10, 11, and 12 from worksheet number 7 in chapter 3. If you have questions, make sure you mark them and bring them to class.